Hi everyone and welcome back to the channel. This is a video I've been getting a lot of requests for, a complete guide to configuring OpenVPN on pfSense. So here it is. If you are new to OpenVPN, when I say OpenVPN, this is the client VPN solution, meaning end user client connectivity. Be it a Mac, Windows, Linux, iOS, Android, they can connect using OpenVPN to the pfSense network. And this is not a IPsec site-to-site VPN where you connect branch sites together. In case if you're interested in watching IPsec site-to-site VPN, I have a separate video for that. So you can click on the video card at the top right corner. I'll also put the link in the description as well. This will be a bit longer video, so if you don't want to watch the whole thing, I have listed the chapters below that you can jump right into. In this guide, we'll walk through setting up a pfSense OpenVPN server using a local user authentication. You can also use Radius and LDAP as well, but we will save that for another video. Here is a plan. We will configure the OpenVPN server on pfSense from start to finish, and then we will test the connection from 3 different clients. One is Windows and an iOS device, and of course from an Ubuntu server as well, which is hosted in AWS. I'm so excited, so let's get started. If you like what you're watching, please like this video and subscribe to my channel. That would encourage me to create more such content like this one. And if you got any suggestions or comments, please let me know in the comment section below. Let's get back into the step-by-step guide on my website. So this is the topology that we are going to work on. On the pfSense OpenVPN client side, we have a network of 10.100.0.0/24. And on the pfSense LAN side, I have 10.1.1.0/24, and I've got multiple hosts on the LAN side as well. We'll be using these hosts for testing. We may not use the same IP, maybe different ones. We will configure all these steps that is mentioned over here, choosing from authentication method, firewall rules, and of course, testing the connectivity. The first thing you need is the pfSense firewall with the static IP configured, or dynamic IP if you have DynDNS. And if you don't have DynDNS with the dynamic IP, when the IP changes, your OpenVPN will stop working and the client will lose the connectivity. To connect to the VPN, you need to have an OpenVPN client installed on the system. Under prerequisite, you can click here to download the OpenVPN client. As you can see, it's available on almost all the platforms. So depending on the operating system that you use, you can download the software. Since I use the Mac, it is showing the Mac software. So for testing on this lab, I'll be using a Windows machine. So I'm downloading the Windows one. So click on View, Download.msi. It will start downloading the file and you can install it on the Windows machine just like you would on any other software installation. I'm not going to show that. I already installed the OpenVPN app on my iOS device from App Store. We will see the installation of OpenVPN on Linux in Ubuntu during the testing. So stay tuned for that. Let me log into the pfSense now. I don't know why I have a lot of traffic spike all of a sudden. Anyways, let's get going. Don't worry about the private IP starts with 192.168.1 that you see on the WAN side. The public IP is configured on my ISP router and I'm doing one-to-one NAT here. So basically any traffic destined to my public IP will get NATed by the ISP router and hit on the pfSense firewall. Let me add a widget that will show you the connection status of the OpenVPN. So once the user is connected, you can see the list of users who are connected and what their public IPs are, which is pretty cool. Click on OpenVPN. No OpenVPN instances defined. That's fine, because we haven't done any. Step 1. Create the user for local authentication. We can choose authentication for the VPN with the local account, Radius or LDAP. But in this video, we'll see the local authentication with the user account that is created in pfSense. Let's go ahead and create the user account. Click on System and User Manager. That's where you manage the users in pfSense. Click on Add to create new user account. Add the username, password, confirm password. You may add the full name, although it's not needed. It's optional. You can also put an expiration date, which is pretty good feature. For example, when you want to let your third-party vendor to connect to the network for a week or two, and you don't want to create a temporary AD account, you can create an account here and set an expiration for a week or two, depending on the requirement. I have not seen this user expiry feature in Palo Alto. In fact, I raised this request with the Palo Alto account manager long ago, and I'm not sure if they have implemented this feature now or not. And of course, I'm not comparing Palo Alto with pfSense, but just saying this is a good feature to have. So I'm not setting the expiry date now. Click on Save. Oops, the password didn't match. Let me correct that. Alright, the user account is now created. Step 2. Install OpenVPN client export package. Once you set up the OpenVPN, you would have to send the configuration to the end user. So the client export package is needed to download the OpenVPN configuration file, which can then be sent to the user to connect to the VPN. So you can download the configuration, client software from the client export package page. And this client export package software isn't available out of the box, so you have to install that. To install that, click on System, Package Manager, click on Available Packages, search for OpenVPN. This is the one. Click on Install and click on Confirm. Installing now. This would take time depending on your internet speed. Let me fast forward this. Alright, it's done. Step 3. Configure DNS record for your VPN. Although this step is not needed, but if you own a domain name, it is best to have FQDN pointing to your public IP. So instead of just using some random public IP on the internet, you could have a name, let's say vpn.getlabsdone.com or something like that. If you want to test the connectivity with the just public IP, you can just ignore this step and move on to the next one, and you can still use a public IP. Okay, so this step is not mandatory. One thing I want to point out here, I would be using two public IPs. One that starts with 94 is my VPN public IP that's on the pfSense WAN side at my site. And when I test the network, I'd be connecting to a different network where the internet IP starts with 37.x.x.x. So let me add a host a record now. Click on Add a record. Enter a name. In my case, it's lab-VPN. Let me put that in here. I'm not using the Cloudflare proxy here, and TTL I'll keep it 1 minute. I don't want the FQDN to be live for more than 1 hour on the internet after I delete the entry. Let me put the comment so I'll remember to delete this later on. Note, this rule needs to be deleted. Save it. Oops, I missed the important part, which is the IP address. Let me paste the VPN IP starts with the 94 and save it. We have now completed all the prerequisites. Step 4. Configure the OpenVPN and its policies. So to configure the OpenVPN, click on VPN and click on OpenVPN. You can click on the server by clicking Add here, filling all the details manually one by one. But I prefer to choose the wizard, which is pretty easy. You can click on the wizards option by clicking on the wizards tab. In the type of server, you remember I said we can have multiple authentication sources. So we would be using the local user authentication. So choose the local user access and click on next. Now you need to create a CA certificate for the VPN. So enter a descriptive name, GetLabsDone OpenVPN. Key length, let me change from the default 2048 to 4096 bit. You can leave the rest of the things or you can fill them up. It's up to you. Common name, getlabsdone.com, country code, state, city. Once done, click on add new CA. Country code didn't match. Let me correct that. Done. Click on add new CA. Next, you need to configure the server certificate. The certificate by default you see here is a pfSense GUI access certificate. And if you click on next, it will use the same certificate. And I don't want to do that. I'll create instead a separate certificate for the VPN. Click on add new certificate. So same process like we did before. Fill in the details. This is self-explanatory, so I don't need to spend much time here. Once filled, click on create new certificate. The certificate creation is now complete. Let's now configure the OpenVPN service. In the description, enter a name, GetLabsDone OpenVPN. Protocol I want to keep default, UDP on IPv4. So the interface is WAN. I only have a single WAN interface, so if you have multiple dual uplink or dual WAN interfaces, you may choose the one which you want to use it for the VPN. Local port, I can change it to whatever the port I want, even 443, but I'm leaving the default 1194. I'm leaving the cryptographic settings default. You don't really need to make any changes here, but the tunnel settings are the important ones. So let's talk about that. When the client connects to the OpenVPN, it gets an IP. That IP address is provided by pfSense OpenVPN instance, just like how the DHCP allocate the IP. Here you define the network you want the client to get. One thing to note, you cannot have the same LAN site network 10.1.1.0/24 in my case on the tunnel side as well. If you do that, the communication will not work. Let me confirm the OpenVPN subnet on my diagram. Okay, it's 10.100.0.0/24. Let me update that. Now in the IPv4 local network is where you need to define the LAN address which you want the user to access. Here it should be, in my case, 10.1.1.0/24. In the concurrent connection, if you have multiple users, you could add how much ever you have, like 10, 15, 100. In my case, I'm just putting just 5 because I don't have that many users. This is the lab testing. This is fine. Let me update the DNS configuration. If you have a DNS name, you may put it here, getlabsdone.local, and in the DNS server, if you have an internal DNS, you may put it here. Since I don't have an internal DNS server, let me update 8.8.8.8, which is the Google public DNS server, and 1.1.1.1, which is the Cloudflare DNS server. Click on next. There are two options here. Both of them take care of the firewall rules. The first rule that will allow the traffic from anyone on the internet to port 1194 on UDP. So if you look at the firewall rule now, you only see a single rule at the WAN side. So after completing the wizard, you will have one more rule which says I'm listening on any address on the internet on port 1194. I'm allowing the traffic, not listening. I'm allowing the traffic. We will check that once we complete the configuration. And the second rule is for the OpenVPN tunnel. And it will allow OpenVPN user to send traffic through the tunnel. So we can access all the resources behind the pfSense firewall. So in the rules section, you will see another tab gets created that says OpenVPN, and you can manage the OpenVPN rule from there. Click on next and we are done. Click on finish. You see, we just completed the configuration. Let's get back into the rules window and click on refresh. You can now see rules created under WAN. This will allow all users from internet to be able to connect on port 1194 or whatever the ports that you defined. Great. We can also see another tab is created called OpenVPN. When you click on that, there is a policy underneath as well, which will allow all the traffic on the tunnel. So you can fine tune if you want to allow only specific traffic, but by default, it's allowing all. Step 5, export the OpenVPN configuration to the user. Alright, we configure the OpenVPN and the pfSense is listening on port 1194. But how does the users be able to connect? You need to tell the users, right? Hey, use this configuration to connect. So you need to share the OpenVPN configuration to the end user. The way you would do that is by going into Client Export tab, which we installed just a while back. And you should see a configuration export at the bottom. But why is it I'm unable to see this option? Because we have to do one more change here. So let's get back into the configuration again. Click on server and edit the OpenVPN configuration. In the server mode, change it to remote access user authentication. Unfortunately, this option isn't available during the OpenVPN configuration wizard. Scroll down and click on save. Back to Client Export tab and scroll down, and here you go. You now have an options to download the OpenVPN client, also the configuration. The inline configuration is a OVPN file that can be imported into any of the OpenVPN client irrespective of the operating systems. We also have an options to download the client for the respective OS. Let me download the configuration file. I have downloaded the configuration file. It's downloaded now. Let me edit the file to point the DNS to my newly created domain name. So let me open this in text editor, open with other, text editor, open. Let me verify the DNS again. So get back into terminal, ping lab-vpn.getlabsdone.com. Yes, that's my public IP, starts with 94. Let me copy the FQDN and paste it in the configuration file. Done. Save it. So I can now send this file to the end users who wants to connect to the VPN. So if you don't want to use the FQDN, you can just send the plain public IP and the user will be able to see the public IP in the configuration file. Step 6. Test the OpenVPN connectivity on Windows machine. So let me copy that Alright, back to the Windows machine. Let me paste the file here on the desktop. Let me double click on the configuration file to import. Say yes. As you can see, the file is now imported. Before I connect to the VPN, let me quickly check the routing table on the Windows. That's what decide which way the traffic should go. Open the command prompt, ipconfig, hit enter. This is the IP that I have. To check the routing table for IPv4, type route print -4 and hit enter, and I have a route towards my gateway. That's where all the internet traffic is going, and there is no route for the pfSense LAN side because I have not connected to the pfSense OpenVPN. Let me now initiate ping from the Windows machine. Ping 10.1.1.1-T, which is my pfSense LAN side gateway. It's timing out. Let me also ping other hosts in my LAN side. Now towards the Linux host, ping 10.1.1.10-T. Oops, let me try again. -T. That's not responding either. I have another Windows host. Let me ping that as well. Ping 10.1.1.11-T. Let me keep this down. Now let's go ahead and connect to the OpenVPN. Go to the system tray and right click on OpenVPN and click on connect. It's prompting for the credentials. Let me enter the username and password and click on OK. Alright, I got connected and I also got an IP address 10.100.0.2. That is good. And as you can see, I'm getting a response to my ping as well, which is great. So which means I have a connectivity. I can also test a TCP connection with the RDP to my Windows server on the pfSense LAN side. Open the remote desktop connection, enter the IP 10.1.1.11, click on connect. It's prompting for the username and password. Enter the username and password and click on OK. Ignore the security warning. Here you go. This is my Windows server. Let me maximize a bit and let me go to CMD and type ipconfig. As you can see, I got an IP address 10.1.1.11, which is the pfSense LAN side. Great. Let me close all that. If you check the routes now, you can now see 10.1.1.0/24 is taking the OpenVPN gateway, which is 10.100.0.1, which indicates that we are on split tunnel. The internet traffic goes out locally and private traffic goes via OpenVPN. Step 7. Let's now test the full tunnel with the same. So sometimes you want to send the whole traffic through OpenVPN. So let's see how we can do that. First, let's check the public IP of my Windows server now. Click on what is my public IP. As you can see, I have a public IP starts with 37.x.x.x. Great. Let me now go back to my pfSense to enable the full tunnel. Let me go to VPN, open VPN, click on edit, scroll all the way down and check the option that says force all client generated IPv4 traffic through the tunnel. When you clicked on that, the LAN side IP disappeared, which means there is no point in specifying the LAN side IP here because the whole traffic would take the OpenVPN route. Let me uncheck, it appeared again. Let me check back. Now we are on full tunnel and scroll down and click on save. Let me switch back to the Windows and check the OpenVPN status. Let me click on reconnect. It's connected now. To verify the connectivity, let me now refresh my site showing the public IP. It is showing 37. Click on refresh. As you can see, it is now switched to my pfSense WAN side IP address starts with 94. Let's now check the routes. Remember, we had these routes before. Let me reissue the command again. You know what? Let me open new command prompt and enter the route print -4. As you can see, there is a new default route added with the less metric, which means it will take these routes. Let me do quick trace route to the public IP, tracer www.google.com. As you can see, my next hop is pfSense OpenVPN gateway. Wonderful. Let me now disconnect the OpenVPN. Right click, disconnect, rerun the tracer again, and this time it is taking my local route, which is 172 series. And when I run the route print command, you see the second default route with the less metric is now gone, and I only have a local route that is pointed to my local gateway. Let's refresh the public IP again, and I am back to my IP starts with 37.x.x.x. Let me connect again, enter the password, click on OK. It is now connected. And I should also be able to access the pfSense firewall from here, which of course you can restrict with the help of policies. Refresh and I am back to my pfSense network. Open new tab and 10.1.1.1. Ignore the security warning. Enter the username and password and click on sign in. Oops, that's wrong. Oh, I changed the password. Let me try again. Enter the new password. Let me maximize. Remember, we had a widget added for OpenVPN in the pfSense dashboard. It is showing that I am connected from public IP starts with 37.x.x.x, which is of course my public IP on the client side. I can even disconnect the user if I want to. Let's also monitor the firewall logs, which will be useful for troubleshooting. Step 8. Check the OpenVPN logs for troubleshooting. To see the firewall logs, go to CRS System Logs. Click on OpenVPN. Here you can see the logs related to OpenVPN, which will be useful during the troubleshooting of OpenVPN connectivity issue with the user. As you can see, there is a system log that says user Saifuddin authenticated. That was our previous test. To see the actual traffic in OpenVPN tunnel, we can go to Firewall. You know what? I just remembered, although I created the policy for the VPN, I have not enabled the logs. So which means even if you go to the firewall logs, I won't be able to see them. Let me do that now, else there won't be any traffic. Click on Firewall, Rules. I am at the WAN rules now. First, let's enable the logs in the WAN side where the end user connects for the VPN. And this is the rule that we created during the OpenVPN configuration. Click on Edit icon. In the bottom under Extra Options, check the option that says Log Packets that are handled by this rule and click on Save. Before applying the changes, let me also enable the logs for the traffic that is taking the OpenVPN tunnel. Click on OpenVPN, and this is the rule that I created for the OpenVPN tunnel traffic during the initial setup wizard. Click on Edit. Currently everything is allowed, that's fine. And do the same, check the log option and click on Save and apply changes. I can now go to CRS System Logs and Firewall. There are a lot of logs. Let me filter the one which I am looking for. Click on Filter. I'm going to look for anyone that is trying to connect to the OpenVPN from the internet. In the destination port, I put 1194. In case if you have changed the port configuration, you may put that in here. And it says no logs to display because we enable the logs on the policy now. In order to get the logs again, someone on the internet has to connect to the OpenVPN. Okay, so let me disconnect myself, disconnect and connect back, enter the password again and click on OK. It's connected now and apply filter again. And as you can see, there is a log that says someone on the internet tried to connect to the VPN using the public IP starting with 37.x.x.x, which is of course my client side IP. What if you want to see the tunnel traffic? So let me change the filter to source IP, which is 10.100.0.0/24, which is my OpenVPN subnet. It also says no logs to display. That's fine because we just enabled the logs. Let me initiate some traffic now. I will initiate some RDP connection again and close it. I'll also initiate some pings, ping 10.1.1.1-t. It is responding as well. Let me also ping one of the Ubuntu hosts 10.1.1.10 and that is responding as well. And another IP 10.1.1.12 which doesn't exist. It's timing out as expected. Let me refresh the log. It's still not working. That's weird because it is not just the traffic that I initiated. There will be a lot other traffic as well. Let me change the source IP to my OpenVPN IP, which is 10.100.0.2. There you go. You can see a lot of logs. Some are even going to the internet. But for some reason, the subnet filter not working. Not sure why. I might have to check that later. If you know the reason, you may let me know in the comment section below. And these are my ICMP traffic logs. You can also see the one 10.1.1.12 which didn't respond, but it's going via the firewall. Where did my RDP traffic gone? There you go. At last, that's my RDP traffic that we allowed, and everything is working perfectly fine from the Windows side. However, this video is not complete without testing other operating systems such as iOS and Linux. Step 9. Test the OpenVPN connectivity from iOS device. Let me now switch to my iPhone. So I already exported the file to my iPhone now. You can see the first one is my pfSense OpenVPN. So I have a secondary one which is the AWS VPN. So the first one is a pfSense VPN. Before I click on connect, let me initiate some ping from the iPhone to the pfSense LAN side IP. Let me switch to the ping application, which you can download from the App Store. Enter the IP 10.1.1.1 and tap ping. As you can see, it is timing out. Let me now switch back to the OpenVPN and click on connect. It's connected now. Let me now switch back to the ping utility. You can see it's now responding. Those timeouts are most likely previous ping requests. Just wait for a few seconds and it is now stable and the ping is now working perfectly fine. I can also try RDP from my iPhone. So let me switch to the Windows app in my iPhone and tap on previously configured RDP connection, configuring remote PC, which is a good sign. And here you go. The same exact server that we logged in during the OpenVPN test on Windows machine, I was able to log in from my iPhone as well. Let me switch to the OpenVPN, disconnect that, and the ping is now timing out. Perfect. Step 10. Test the OpenVPN connectivity on Ubuntu machine. For that, I had to set up a new server in AWS. So I already powered my Ubuntu machine and it got a public IP starts with 3.x. Let me copy that and try to log in the terminal SSH. You know what? Before that, let me check the files that I have. As you can see, I already have the OpenVPN file and SSH key for the AWS VM. The OpenVPN file I already transferred to the Ubuntu machine, which is already there. We'll check that as well once we log into the Ubuntu machine. So let me SSH now, SSH-I, and then the SSH key, Ubuntu the public IP, paste that here, and I'm in. And if you do the ls here, you can see, as I mentioned, I already transferred the OpenVPN file here. Using this file, you will be able to connect to the OpenVPN. I used the scp command to transfer the OVPN file from my local machine to the Ubuntu machine. And I already downloaded the OpenVPN as well. So to download the OpenVPN, you just have to enter a few commands, sudo apt update and hit enter. It will update the repository. To install the OpenVPN, type sudo apt install OpenVPN and hit enter. As you can see, 0 upgraded, which means I already have it installed. So now let's go ahead and connect to the VPN. So to connect to the VPN, enter the command sudo openvpn --config and call the OpenVPN configuration file here and hit enter. It's prompting for the username. Let me enter that, and password, let me enter that as well. It is now shows connected. And I got an IP address, if you look closely, 10.100.0.2 like before. If I had another session to the OpenVPN, then the IP would have become 10.100.0.3. If you want to disconnect the VPN, you can simply use Ctrl+C. So let me not do anything here. Instead, let me open a new window, SSH into the same host, SSH host key, Ubuntu. I forgot -i. Let me add that -i and the public IP. Okay, let me disconnect here. And if I do IP-ADDR, you see the loopback address and the private IP of my AWS host. Let me see what interfaces I get when I connect back to the OpenVPN. Enter the credentials and I have now connected. Let me switch to the other window and enter the command IP-ADDR and hit enter. And if you look now, you got a loopback interface and the physical interface, and finally the OpenVPN tunnel interface with IP 10.100.0.2. Remember, we had full tunnel enabled. If I check the public IP here now, curl ifconfig.me, you can see it is showing my pfSense public IP starts with 94. Awesome. Just like before, I can also ping my other Linux host from here, 10.1.1.10, and it's responding. I can also SSH into my local Ubuntu machine, SSH safe@10.1.1.10, enter the password. Here's my lab Ubuntu machine with the IP 10.1.1.10. You know what? Let me create a file here, nano-hi.txt. Let me add something. This is the text I edited from AWS host. And to save this, Ctrl-O and hit enter. Cat hi.txt, and the file is saved. Great. Let me now switch to my local Ubuntu host. Login. Open terminal. IP-ADDR. Yes, this is the right host. cd ... and ls. Here is a file that we created. Let me open it, cat hi.txt, and this is the text I modified from the AWS host. And that's it. We configured OpenVPN, tested that on the Windows machine, iPhone, and a Linux machine. This was a longer video. I hope you got some value from it. Please like this video and let me know if you got any questions or comments in the comment section below. So as always, we'll see you guys on the next one.